Alright, welcome to our video on graphing trig functions. For me, I call it the easy way because we've done it for years the other way. And if you do it the way I'm going to show you today, I consider it the easy way. Visit our website at 3mathguys.com and please subscribe to our channel below. We try to put a bunch of content on for you guys. And if you have any requests for something you'd like to see done, or if you want to see how we do certain things, go ahead and just comment and we'll see if we can get it up there for you. Anyhow, we're going to graph a function today, and we're going to graph the function f of x, right? Now, in the past, there have been various approaches to it. A lot of times they graph the parent function and then they shift it and they do all that stuff, or they go through and you identify the period, the amplitude, you do all that stuff first, and then you go through and you start graphing it. What's nice with function families and graphing using transformations is that we can now, just like in my other video, you can now go through and apply all the transformations to this function right here without having to graph it first. All right, and then when we graph it, we will be done. So we'll apply all the transformations to the table, we will plot the points, and you will have your graph and all transformations taken care of. So where do we start? We start here at the parent function. This is the parent function right here, p of x, which is the sine of x. But for our purposes, I will call it x sub p to represent the domain of the parent function. Okay, and the nice thing with function families is that once you know what the family generally looks like, and sine is perfect for this, you really only need to know certain points. Like I would only want to know this point right here at the zeros, right? And so you can clearly see there are three of them, right? I would also want to know this point up here and this point down here, right? All the other points basically the same, and if I know this general shape of the function, it's all going to work out in the end. Right, so as you can see in my table down here, I've taken those specific points, all the points that I felt were important, which are my zeros, which are at 0, pi, and 2 pi. And then I've taken my maximum, which is at 1, and my minimum, which is at -1. Now, this is obviously just for one period, and that period is from 0 to 2 pi. Okay, and my argument is if you can graph one period, you can graph the whole function because everything else is just copies of it, right? So at pi over 2, you can see that it's at 1. At 3 pi over 2, you can see it's at -1, and now we have the table for the parent function. And using that, we're going to go ahead and transform this table into the table for f of x. Okay, so here we go. If you recall from my other videos, so if you're not sure what I'm doing with all this transformation stuff, go back and watch our first video on function transformations. It gives you a rundown on how it works. Anyhow, the first step to applying transformations to a table is to go through and reorganize all these transformations by who they're affecting. Right? Are they affecting the range, which is our f of x, or are they affecting our domain, which are the x's? Okay, and if you look at it, this plus 3 moves up 3, right? This -2 right here will stretch and flip the y's. So this is a, you will take f of x and basically multiply it by -2, right? This right here is a horizontal shift to the left, and this is also a horizontal stretch, okay? Okay, so what I'm going to do is I'm going to go ahead and I'm going to take all the guys that are affecting my range, which is the plus 3 here and that -2 here, and I'm going to go ahead and organize it with the range so that I can transform the table properly. So moving that 3 over and the -2 over, you will see that I will get f of x minus 3 over -2. On the other side, nothing has changed, so that will stay the same. Now, if you remember from the other video, what this is basically telling us is, if I want to take the range from f of x and transform it back into the parent function, I will simply subtract 3 and divide by negative 2. Similarly right here, if I wanted to take the domain of f of x and turn it into the domain of the parent function, I would multiply by 2, then add pi over 4. So what we're going to do now is, what do we do to the parent function, because that's the table we have, and to get to the f of x. So let's do it. Here we go. If I set it equal, because, well, that's really what it is anyway, right? I can solve this using inverse operations, and you would get which means basically that if I take the range of the parent function and multiply it by negative 2, then add 3, I will get the range of f of x. Similarly, we can do that with the domains as well. Inverse operations here as well, and you will get that if I take the domain of the parent function, subtract pi over 4 from them, and then divide them all by 2, I will get the domain of the parent function f of x. So now we have our transformations. This is what we're going to do to turn the table for the parent function into the table for the function f of x. So let's do it. Here we go. Let's start on top. Okay, it says take all my functions, all my numbers in the domain, subtract pi over 4 and divide by 2. So x sub p minus pi over 4 divide by 2. Alright, I'm going to walk through one of them and then I'm just going to give you the rest. So the first one, let's do pi. Okay, so pi minus pi over 4 is 3 pi over 4 divided by 2 is 3 pi over 8. So that would change pi to 3 pi over 8. Okay, on the bottom, I would change all the range of the parent function by taking them, multiplying them by 2, and then adding 3. So using this point again, that means I would take negative 2 times 0, which is 0, plus 3, and there you go. You would get 3. Following this process for the rest of them, you would get this table right here. Okay, and you definitely want to walk through the process of just doing this. Okay, I of course am cheating because I've done this ahead of time. Okay, now we have the table for the function f of x. I just simply have to go through and plot the points. And if you look up here in the domain, you already kind of know how you're going to have to scale your graph. And that's the thing that's going to happen that I'm going to talk about next, is scaling it. If you look up here, you always want to scale it based off of the highest denominator, or basically this, the smallest piece we're cutting it into. So in this situation, it's a denominator of 8. In other words, I'm going to be counting by pi over 8s. Okay, so let's go ahead and scale the x-axis first. So here's what I always teach my guys to do. As I'm walking through here, I'm going to go ahead and count it in terms of pi over 8s. So this is 1 pi over 8. This guy would be 2 pi over 8. 3 pi over 8, 4 pi over 8. Okay? And then 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. Now, if I were to do this as, say, homework, I would do it in pencil, so then I can then convert all my fractions. Because we all know 4 pi over 8 is really pi over 2. And we all know that 8 pi over 8 is really pi. Okay? I know I got to go the opposite direction too, so I'm going to do a few of these on the left. So that's negative pi over 8, this is negative 2 pi over 8, negative 3 pi over 8, and negative 4 pi over 8. Okay? The y-axis is pretty small, so I'm just going to go ahead and count by ones. So 2, 3, 4, and 5. Okay, I'm not even going to bother with the bottom because I know it's not going to go down there. So now it's just a matter of graphing applying the points and connecting all the dots, which by now, since you're in Trig, you guys should all be pros at. So anyhow, negative pi over 8, comma 3, pi over 8, right here, comma 1, 3 pi over 8, so 1 pi over 8, 2 pi over 8, 3 pi over 8 right here, comma 3, okay, 5 pi, so here's 4 pi, here's 5 pi, alright, 5 pi over 8, or comma 5, okay, and then last 7 pi over 8, comma 3, so here's 8 pi over 8, here's 7 pi, okay, and as you can see, since I know it's a sine function, there you go. There is one period of my function f of x. Now, how do you get the second period? Well, basically you just repeat. If you have to go to the right, then I would basically just start counting it off, right? As you can see, going from here to here, it's 1, 2 steps, and then we hit a minimum. 1, 2 steps, and I'm at 0. 1, 2 steps, and then I'm at my maximum again. Right? 1, 2 steps, and I'm at a 0 again. So if I were to pick up from here and continue, I would basically just do the same thing. Go over 2 steps, and then minimum. Right? On the left, because I'm going this way, I'd go over 2 steps, and I would go maximum. Okay? And so you're starting to see where the next 2 periods are forming. Okay, so I know a lot of times we want 2 full periods. That's how you would do it. Okay, the amplitude is 2 because your zeros are now shifted up to right here. So this would give you an amplitude of 2. This would also give you a period, which you can now simply count, right? 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8 gives me a period of 8 pi over 8 or pi. And there you go, guys.